5 says, is the triangle formed by A, B, and C a right triangle? So we're going to connect these points to determine if any of these create a right angle. And we may not be able to determine it visually, so we're going to use the Pythagorean theorem to calculate how long each side is. So each one of these right triangles will help us find the hypotenuse, which is the actual side length of the triangle drawn in black. So this one is a 3 by 6. The green is a 3 by 8. And the red is a 3 by 5. So for the red one, we have 3 squared plus 5 squared equals c squared. That is 9 plus 25, which is 34. So to find c, we're going to use the square root of 34. But we don't want to round that because we want to figure out exactly. And if we estimate that value, then it might throw off our answer at the end. Now we're going to do the green triangle. 8 squared plus 3 squared equals that hypotenuse squared. 8 squared is 64, 3 squared is 9. When you add those together, you get 63. So we square root both sides, and c equals the square root of 63. And now the blue side. 6 squared is 36. 3 squared is 9. So c squared is going to equal 45. And to undo a square, we use a square root. So c is equal to the square root of 45. So now to figure out if that black triangle is a right triangle, we're going to compare the two short sides added together to the longest side. And the longest one is that square root of 63, because the square root of 63 is longer than 45 or 34. So we've got square root of 45 squared, because they would still be considered legs. So we would use the Pythagorean theorem to check. And then we'll want 34 squared equals 63 squared. Squares and square roots undo each other. It's like dividing by 5 and multiplying by 5. You get back to the number you started with. And when you add 45 and 34, you get 79. But 79 is not equal to 63, which means that this triangle, ABC, is not a right triangle. Because it does not satisfy the Pythagorean theorem.